Hi everyone, my name is Ford Smith. I work with Regenerative Land Solutions, and today I'm going to talk about looking at agriculture through a biological lens. In nature, plants grow like this picture. There's the sun, plants do photosynthesis, they exude sugars out their roots. Specific sugars can attract different bacteria or fungi to break down minerals that plant might need at that specific time. Copper or boron, whatever the plant needs. And then that fungi can directly feed the plant, or in a lot of situations, the protozoa break down and eat the bacteria or fungi, and that releases the nutrients for the plant. That creates a really healthy soil system. We're trying to simulate that in agriculture if we can. This will help all these benefits of healthy soils. You result in natural nutrient cycling, fewer chemical inputs, greater profitability. Germination rates for the plants we're trying to grow increase, and you end up with less weed pressure. I'll go into that here in a minute. The healthier plants are more disease resistant and more insect resistant as well. This natural nutrient cycling creates more nutrient dense crops, which is healthier food for people or healthier grass for cows. Bacteria and fungi, they create micro and macro soil aggregates, which creates better soil structure, which allows for more air and water holding capacity, less compaction, and cleaner water. In agriculture, we have all sorts of disturbance. We're constantly disturbing the soil ecosystem, be it through tilling or pesticides or salty chemical fertilizers, and this pushes us backwards on this ecological succession. As you can see, very bacterially dominated soils like annual weeds and grasses. The crops are generally trying to grow, and perennial grasses want a more balanced system, and then it goes up to trees. So how do we manage for healthy soils in soil biology? Most people, they take chemistry tests, it tells them how much nitrogen, phosphorus they need. But we like to layer in biology tests on top of that. And this helps us get a good picture of what is going on in our soil biology. So here's an example of one of those. You can see we've got total bacteria, total fungi, activity levels. We go through all the ratios. And then you got your protozoa as well, and that's what helps create your natural nutrients.
They always do it. I always look at all my mirrors.
So there you go. So we got started on this journey with my dad, Vern. This is a picture of our home ranch, our first example we started with. I've been moving hand line on these fields since I was a little kid. But this field, you can see this top steep hillside section always struggled. So he did a soil biology test on that section and his fields in general. And what he found was that the soils they had low biological activity. So what he did was he treated them with a probiotic and a prebiotic for the soil 2 years in a row. And this is the early spring. You can see that helped with 2 treatments in 2 years. That side on the left had significantly thicker and healthier. This is a grass alfalfa stand. And then on the untreated side, it was still thin like it always was. We happened to have a professor at MSU, Jed Eberly, come by, and he took 2 samples. So that first test we showed you, that was direct microscopy. That's a relatively coarse test that's easy and affordable for folks to do. But Jed, he took 2 samples for DNA sequencing. And what he found was on that untreated side, there were significantly more bacteria associated with unhealthy acidic soils. And this is something these fields have struggled with for 20 years. They've always been acidic, but getting that biology healthy helped balance out the system. And this got us excited about doing more research and trying to dive deeper into how we might be able to do this at scale. So we partnered up with Dr. Jed Eberly and MSU, and then some neighbors down the road at AMB West. We set up a replicated study. We were testing that the same products Vern tried on his field, Provide and Revive. They're a wide spectrum, highly diverse probiotic, and Revive's a food source for the fungi. And then we tested it against The alternative out there, there's lots of bacteria that's made in a lab. They pick out like specific bacteria they think might be helpful. So we did some Tanio products, Spectrum and the food source Nutrinate. Originally, we had set up with compost. We were excited about that, but it was logistically very difficult to get compost out there and prohibitively expensive. So we stopped it after the first year, but we did 2 treatments on 2 sites. One was a irrigated alfalfa field and the other was a irrigated pasture. And on both of these, we just put the biology on top of the regular conventional fertility program. What we found after 2 years was the organic matter, soil organic matter, your carbon went up on the diverse treatments with Provide. And then we also saw more nutrients being available. We did chemistry testing as well on these fields. So there's more natural nutrient cycling on the biologically treated sections. And this resulted in more and higher quality feed. We had increased dry weight on the Provide fields, and we also had higher relative feed value on both biological sides. So with these ones, we were just doing biology over the fertility program. And what we really would like to do is have folks rethink their entire fertility program and try and make it more biologically friendly on all levels. So same at A&B West, we got a brand new field. That was going to be a new grass alfalfa mix. And we split this one just in half, but we did testing and we devised a biological approach on one side where we did those biological products. And then we did fish hydrolysate for the nitrogen source. And then we did a less salty, which is salt is the main problem with a lot of these chemical fertilizers. But we did a G22 in that mix. And then on the other side, they just did their traditional, what they always do program. Here you can see the testing, pre-treatment testing. These fields were bacterially dominated, which on that ecological succession chart we saw is going to result in more annual grasses and annual weeds. And also it had a very low biological activities. So that first summer, after treating it, we did this in the fall. We had MSU help us set up a sampling grid to look at weeds. We threw all these hoops on both sides. And then here you can see some pictures we took. On the biological side, there was significantly less mustard. And when we did the sampling, we saw there was about 4 times as many weeds on the traditional chemistry side. Just having that soil not be balanced for the perennial grasses we wanted, as you could kind of tell from the pre-testing, it was going to be set up to have more of these annual weeds. We also tested the feed value on these fields after they cut and baled the hay. Slightly higher protein, a little bit higher relative feed value on the biological side. We did tissue testing. You can see the nitrogen was higher and the potassium was higher on the biological side. Just having healthier soils, cycling the nutrients that the plants need to create these healthier plants. And if you look closely at these pictures, you can see on that traditional, on the chemistry side, there's more bare ground. The germination wasn't as good. It's hard to get perennial grasses to germinate in a bacterially dominated soil without any help. And that you can see on these pictures there. We went back the next spring, this year, 2021. These are perennial pastures, so we wanted to see or perennial hayfields. We wanted to see what we got in year 2, see if these results stayed the same. We had a local NRCS agent come out, help us do these hoop tossing sampling. And we found that we had significantly more cash metal brome on the biological side, still higher production. We also saw that there was those weeds, they didn't just go away, those bare spots didn't fill in automatically. So the chemistry side still had significantly more weeds than the biological side. We do more than just irrigated. There's, on dry land, a lot of people in Montana struggle with annual invasive grasses, like cheatgrass. We had an example in Texas, they have rescue grass that's related to cheatgrass, the same family. And here they were trying to reseed perennial grasses. On the untreated side, you can see it looks like more grass, but that's just all the rescue grass taking over again. And on the biologically treated side, they had more of the grasses that they wanted germinated and insignificantly less rescue grass. We also work with row crops here in Montana, wheat. We have a friend who's a progressive farmer out near Three Forks. He's really excited about biologicals. He runs all his own trials. He had 14 plots set up. 2 of them he did provide and revide from Earth Fort. Granted, this is a really bad year. This is 2 years ago, not a lot of rain, but you can see they had higher yields on the Earth Fort plots and the bio release. That's a different biological he was trialing. They both outperformed the chemical controls. So we work all over the country. Do a lot of work in California, Illinois. We've got tons of resources and case studies on our website if you want to read more. And with that, I'm ready for some questions.
Thanks, Ford. Yeah, anybody, you can just unmute, ask some questions. If your audio is not working great, you can type them in the chat and I'll read them. Want to do that? Sometimes if you're on mute right now, we're not hearing you. Or I sort of have a maybe indirect question to the product and to your the technology you're developing here, but where do you see the opportunity of this going sort of more broadly, maybe in 2 or 3, 5 years for you all, and sort of maybe some other wraparound kind of activity it might stimulate that's that we're not seeing today?
I mean, there's a lot of growth in just what we're doing right now. Most folks, when you talk to them about this is something they've never heard of. So I think there's a lot of potential there. And then also, as you like for the side-by-side example where we redid the fertility program, there's all sorts of biologically friendly fertility products out there. Other companies developing stuff. There's a company we work with that does a fish hydrolysis where they harvest invasive Asian carp, which is super cool. There's companies that are developing different kelp products and just growing there's algae companies. I think it's a local algae company that MSU is working with. So there's all sorts of opportunities for producers and different agriculture professionals to help create biologically friendly products outside of just what we're working with.
Any questions out there? Sue, I see you're unmuted. Matthew?
Yeah, I'm just going to ask, what's your biggest barrier, I guess, when you're selling this to producers, this approach, especially if they haven't heard it before? Is it believing the data, believing the return and the data that you have, or is it just the attachment to the more artificial fertilizers, or what transpires there?
Yeah, most of the time when we generally take more than 10 minutes to explain it. I had to go through it all very quickly, but most folks are interested in doing it. It's more twofold. It's implementing it can be difficult. Like for example, on these fields, they're redoing their pivots so that they can inject it, but generally they're used to just calling up their fertilizer company and they can just do it for them. So it's the convenience of the status quo is very strong, and then relationships. People are used to working with their fertilizer rep, and it just takes a while for them to change over. But most of the time, once people give it a try, you see that it works, they're open to it. But they gotta figure out a way to implement it. Working with something like fish, we've had people who done fish the first year, saw that it worked, and they just didn't want to deal with the hassles of applying fish versus having somebody else come put dry fertilizer down.
Yeah, from an entrepreneurial perspective, I could see it. Well, there's an opportunity. How do we solve that problem, right? Maybe that's not yours to solve. Maybe someone out there is listening who could say, "Oh, I can figure out a way to solve that problem for the folks, make it a little easier for them to apply."
Yeah. That would be great. And like having more partners across the state, applicators who want to get into this. We've got partners that we work with in Montana, but we're still growing and looking for more people.
Leo, would you?
Or,
Oh, go ahead, Leo.
yeah, I was going to ask Ford, does it take specialized spraying equipment, or, I mean, what kind of equipment does it take to distribute it if you don't put it in an irrigation system?
Oh, you can apply it through any regular spray rig. It's slightly different. It's not quite as fine. I think it's 40 microns or larger. So you need to just pull your filters out, and it usually works just fine.
Okay.
So most farmers who've got their own sprayers can do it, but there's a lot of people we work with in Paradise Valley who don't even own their own fertilizer spraying equipment.
Okay, thank you.
Ford, would you put your contact information in the chat if you wouldn't?
Yeah.
So people can grab it there, and like excuse me, like I said, we should have this together after the recording goes out too, with all of your contact information in it for folks, but just in case somebody wants to reach out to you right away. Thank you, Ford. How about we're right on time. Leo, you want to go second?
Certainly I can do that, maybe.
Yeah. Hey, Ford, if you stop sharing. Yeah, there we go.
There we go. Okay.
Cool, you're doing it on an iPad. I've not tried that.
Well, it's not working very well, so this might be just strictly verbal.
No problem at all. Let's see. I don't know if I can help you. What are you running into?
I'm running into transferring back and forth to programs.
So if you hit the share
Okay.
button, yeah.
Share button. I don't see a share button. Anyway.
Well, it should be on the on the Zoom screen at the very bottom. It should be a kind of in green with an arrow. Share screen. At least that's how it looks like on mine. I don't know about on an Apple. And then I see the bottom of the Zoom window we're on.
Oh, I've got it here, but it's not making the transfer. So we're just going to do a verbal.
Yeah. Perfect.
Okay. So I wish I had pictures, but I don't. My name's Leo Barthelmess. I'm from Malta, Montana. And interestingly enough, Ford's presentation just now supports what we want to do using grazing animals. By increasing the stock density of an animal, we can start incorporating more manure, more vegetation from residual grazing plants that have been grazed and ungrazed. So in order to do that in this arid landscape that I live in, with pastures that vary in size from 100 acres to 4,000, it's cost prohibitive for the ranch to build fences. So we are using a technology called vents, and it's a geofence or virtual fence. We've collared 450 cows last year and the year before. And our goal with the vents product is to increase the stock densities and also prevent the cows from taking a second bite on a grass plant, so that it can replenish its root systems and continue to grow and support soil biology. Our goals are to increase the number of grass plants or vegetative plants on the rangeland landscape. They don't all have to be for livestock forage. We have an abundant wildlife population here that needs support. So we're just trying to minimize or reduce the amount of bare soil. With more vegetation, we can retain more water on the ranch, either as snow melt or rainwater. We try and promote water infiltration from snow and rain. And all of these things will support soil biology. The vents technology is a caller that's warning when she approaches the barrier that we've created. And there's also a physical stimulus that will be implemented if the cow goes beyond the audible. It's just an electronic, kind of like a hot shot. electronics stimulus. So the product has been fairly successful. We've been able to, takes about 2 days to initiate training in the cows. And after the first couple of days, then we can start building a landscape just by using the company's webpage, the boundaries that I want to create. And so we can start to run more cattle on less space and move more often and prevent regrazing emergent growth to promote soil and grass health. We've had very good success. When initially we're getting 98 to 99% compliance in the first 2 or 3 days. One of the drawbacks of it, the batteries in the collars start to fade after about 5 months. So as those collars battery life diminishes, and we lose management ability. But we're collaring in March, and then we turn the cows out on new grass growth, and when the grass is growing fast, we're managing the cattle intensively. And then as grass growth slows down in July, 4 or 5 months later, then it's not so critical, this management. So then we don't use the Vents product very much in August and September. We remove the collars and put them back on in November after we replace the batteries. And then we go back into a winter grazing rotation, and we can use protein supplements and high stock densities to knock down decadent vegetation and put it on the ground so it retards water runoff in a big rain event, and also starts to feed the soil biology. So by recollaring twice a year with new batteries, we're able to manage the cows year round, and we've had really good success doing that. This year, the driest year on record, the properties that we grazed the last 2 winters were far more palatable and far more nutritious for the cattle and the livestock this spring and summer. A little information about how the system works. There are repeater stations. There's 5 repeater stations, cover 95% of the geography of the ranch. And I call up and we have a Zoom meeting with the Vents engineer in San Diego, California, and I have this menu of pastures that I have built, and he said, yes, this will work, and no, that won't work, so we'll have to change that. So we negotiate this pasture movement boundaries that I want to do, and then when we come to an agreement that the technology will allow me to do, then he sends those instructions to the repeater station, which converts a phone signal to a radio signal, and then the radio signal is transmitted to the callers. And then the callers, once they get their instructions, and you can program 16 pastures into a caller, so you could manage your grazing 16 moves, which could be 16 days or 2 months, depending on your goals that you want to achieve. So once the callers have their data information or their instructions, then they communicate directly with a satellite. And so even if the callers don't have line of sight to the transmitter stations, they can pick up those directions. And then once they're programmed, like in rough terrain or forest, then the caller can communicate directly with the satellite. So it's pretty interesting technology, and it works very well. And it's like the early cell phones. They were, the size of a small suitcase, and now they're fit in your pocket. And I'm hopeful, as is the grazing industry, hopeful that we can get some of the bugs out and create more. Because like in my case, we have 60 miles of aged fence on the ranch. It's going to cost $500,000 to replace all that fence. And if we can as it wears out, if we can replace it with the vents technology, we will at a far cheaper price. That will be beneficial for our ag economies, our grazing economies, but it will also benefit wildlife, because I happen to be in an area that has the second longest wildlife migration in North America. The antelope move back and forth from southern Saskatchewan and Alberta to nearly to the Yellowstone Valley around Billings and Miles City, Montana. So it's really kind of important. It's a big deal. Those antelopes struggle a lot to move across this landscape. And so, I mean, and then there we have sage chicken mortalities from infrastructure. And, you know, this technology will enable us to address wildlife movements, increase the nutritional value of our rangelands for livestock as well as wildlife. So that's a really brief overview, and I would entertain questions, because you have questions that were probably, you know, you probably want to know stuff I didn't say. So I would certainly entertain some questions to clarify what I said.
Yeah, thanks, Leo. I've got a couple, but anybody else out there? Take yourself off mute, put it in the chat.
I might have missed it, but are they so effective that you can get rid of your perimeter fencing?
They're not that effective. You know, 95% you could still have animals get on a highway or get into an alfalfa field or a grain field. So no, I don't at this point in time, we can't eliminate the perimeter fence or legal boundary fence, so to speak. That would just be asking for too much liability. But I have, you know, we have a lot of perimeter fence, but we also have 38 permanent pastures on a property. And as those fences fail from age, we can pull them out and not replace them. So that would be a big benefit for many, many ag operations.
That's cool. Thanks.
Yeah.
Leo, I see one in the chat question from Mary Burrows. Is there a concern about after physical fences are down being reliant on a technology that may change or require additional capital investment?
Absolutely. You know, absolutely. I have a lot of anxiety. Once we become dependent on the virtual fence, it's much like part of the agriculture farming communities dependent on chemicals or diesel fuel. And when those prices go up and the commodities don't support that increased price, you're going to be in a bind, literally. No, I absolutely. If the company goes away, what do I do?
Yeah. Well, maybe we need to home grow some innovators to do something similar for Montana, so they're closer. Anyway, I have sort of a technical question. When you go through your day of or working with the company to map out where you're going to move the cattle, do they have to take into account the geography so that they're like, well, we can't actually put a visual fence or invisible fence in the middle of a gully or a draw or something? We have to put it up on a ridge line. So does it limit where you can put them? No? No,
that really isn't. It would maybe over time that would be a consideration, but as we're trying to learn through the technology, it isn't a requirement, because we put them up and down coulees and across different drainages. And one of the systems that we've had good luck with this spring is we will build a rectangle around a water source, and then we will build more rectangles adjacent to the water source. So this spring we had 400 cows on 250 acres for 5 days, and they depleted maybe 60% of the available grazing. And then we built another rectangle, and they had another 90 acres for 2 days. And they had another 90 acres for 2 days. We call it the ladder strategy, because there's a limit to, you know, we have to have water in all these pastures. So as long as they've grazed it and dunged it, they say they won't go back and re-graze it. So we build a ladder to the next water source. When we get to the next water source, then we prevent the cows from going back to the first water source. Because, you know, that in an intensive grazing program, a wagon wheel or a spoke system was very popular, and the cattle came into the same source. But without a visible barrier, we're finding that the cattle keep running into the boundary if it's so narrow at the water source. So, and every time they hit the boundary, they burn battery, and you're trying to save the battery for longevity purposes. So with this rectangular ladder system, they don't bump into the boundaries near as often. And I don't know how they know. Maybe it's just they smell fresh grass, but as soon as that boundary goes down, they'll move across it. It doesn't affect their behavior at all.
Wow, that's interesting. Yeah. Any other questions? Well, we're right on schedule. So having no other questions, we'll have some questions or time for questions at the end. So we got some, hold them for a second, but thank you, Leo. That's really interesting. I'd love to come out and see it at some point, maybe next spring, see how it operates, but it sounds fascinating to me.